Alright, hey guys, so we're back here where we left off last time, I think, I hope, I pray, where we built this sort of thing, and we realized that the gearing didn't work because I'm definitely the smartest human on that planet with no exception whatsoever. I've also realized that this entire thing here is not super necessary. So we're going to take a look at all of that, because here's the thing: if you're putting the screws on the bottom here, you only got this much motion, right, before the 4-bar glides. But if you can put it on the bottom, you're going to get a lot more range of motion. Like, let's just flip it around here. You get a whole ton more range of motion, which I think is just what we need. And then we've got to figure out how to get this front wheel here powered. And then let's get this back wheel powered. And the goal is to build this base within a 30 by 30 frame for the most parts. So we're going to do that first by waiting for my hard drive to open, and once it's open, I'm going to keep this here as a reference to build off of, except we'll have to build it flipped around, but that's not too big an issue. We're going to need to start just 3 of these C channels, so we can actually just copy paste 3 of them in. It doesn't really matter what direction to go in. And then before I do anything, I just want to take one of these channels and then figure out the gearing that we're going to be running for sort of all of the wheels, I guess. So we're going to go and grab some, let's see what you want, spur gears, and then we'll get a high strength 62 gear. Doesn't really matter. Sure. Okay, now we have this rear wheel. We want to move in by, let's say, 2 holes, right? So when we go to constrain it, we just need to find the edge and then move it in 2 holes, and it'll be up top. Okay, and then with that said, you have these 2. Now my question is, do I want to put this 4-bar in front of that gear or behind that gear? So let's say we have this as the back still. We want to put... Okay, so that motion is going to be limited by the wheel. So we're going to want the larger gear up first. No. That's not what we wanted you to do. Is that the right spot? I can never get these right. It's annoying. Still nope. Guys, I'm doing so good. Will you believe it? My chem exam went absolutely perfectly today. I think I got... it's okay. We don't need to talk about it. Paper 3 was rough. That's all you need to know. Gears go on. Now, because we need another gear, 2 gears here to gear down to, we're going to take a 62th gear and use it as a giant idler gear, hopefully. Dude, I can never get this right. Like, am I blind? Okay. 2 idler gears and then this gear here. How does that work out? That puts the front wheel slightly behind or slightly ahead of where it is now. No, it's in line with where it is now, which isn't the most fun and exciting thing in the world. I want to move it just back a bit. Well, the question is, am I going to be pushing more with the back wheel or front wheel? Because if you're pushing more at the back, then you want the back wheel to be closed. You can have the front slightly open. I'm going to take this wheel here and constrain it the edge of this and let's see where it fits. So yeah, the back wheel, if you do it there, will be inside the chassis completely. I'm not sure by how much. So I think we're going to leave it like this. The front, there's going to be a little bit, it's going to be sticking out just the same amount as it here, which isn't too terrible. And then in the back, we've got it just sort of doing its thing. So we're going to go over here and we're going to put down our C channel. And then we're going to constrain these other C channels to that C channel. And for right now, I really don't care what I'm constraining to. I just need a cross brace. When we build the actual robot itself, we'll probably go through the cross brace, and that's okay. And really, like, we'll reposition it later and it'll be fine. And this isn't the only way to sort of do this type of gearing. There's definitely another way to do it, and I want to try that as well, but for now I think we're just going to stick with this sort of design philosophy, at least until I have the other one totally figured out, and then we'll work on that. And I don't know if I'll actually end up CADing the entire robot out, because that seems kind of excessive and tedious, I'm not going to lie. These parts that we made here were fine, right? So we can just copy paste this entire assembly over. We'll have to put in the screws again later, but that's okay. Do I want to take the motors with me? Yeah, why not? Let's take the motors with us. Let's take all of these. Let's take the shaft. Let's take this. Let's take this and this and this and that and this and that and this and that. And there's probably something here that I want to take. Yeah, these two. Because these are all constrained to themselves. So if you have those, then you have just about everything on here. And then we have two of those assemblies that you can just pop on to where you need them to be on your chassis, basically. So at the top, we're going to copy pasta 1, 2. And pray that we built the same side of the drive as we did earlier. Yes, indeed. And those are going to be going on to this one and that one. So let's do this one first. That one seems pretty simple. It's just like third one in. Constrain, inserts, and then let's find. So the reason you use a nut on the inside of the sort of giant assembly is so that when you do the screw, when you put the screw through, it stays on the way you want it to. Hold on, are these the same sizes? Okay. So that way the screw isn't wobbling around and moving around, because it's parallel with sort of the surface that you have right here. And that's super good, because then whatever else you hang off of that screw, the screw is not going to be moving around and it's not going to be causing even more friction. Oh look, I did it right for once. And I think these are all constrained together. Okay, for now, what the heck? We're missing constraint. What did I forget? Easy peasy. Just a little spacer. Spacer will come back and help us. If I can get it to line up. There you go, and then that's fine. And for now, we're just going to take whatever bar we can get and constrain that to the little 4-bar that we have here. And it doesn't really matter how nicely done this is right now, because, quite frankly, it will change later. And they are 8 holes apart. I know this because I counted many times last time. And you'll notice this is going through the gears. I really could care less right now. Like, I really could care so much less. This bar will give us, if we can round the C channel, will show us the range of motion that you can get just from this being sort of out in the open. And that gives you quite a large range of motion. Half of it's going to unfortunately have to be cut off because of where the wheel is. Now, you can flip it around where it isn't interfering with the wheel, but then you're cutting into internal space, and I'm not sure if that's a trade-off that you want to make. But entirely, yes, it's entirely possible for you to like do that and save on internal space. We're also going to make this an assembly, copy pasta, and then if you can constrain those two down, then it will look realistic. This is entirely unnecessary. It's just a gauge for us to know how long the screws needed to be for sort of the interior support piece, I guess. Okay, that's pretty cool. Is it still parallel? With everything? Ah, yes, perfect. Okay, now we need to do the wheel assembly, which is that a Teflon washer? I do not know why we have 3 Teflon washers. Is it so that the wheel can not brush against the gear? Oh yeah, okay. 3 Teflon washers, the gear, the shock collar, the wheel. On the newer wheels, this gap you can shove a washer in and it'll be fine. On the older wheels you can't, so that's just something that you're going to have to play with in real life. But we know that the spacing like this for the wheels does work, because most people build a drive like this, with 6 holes across. So we're going to just take this entire assembly, paste it in, and then we should be able to constrain it, if we did everything right, to the edge of the C-channel and call it a day. And I forgot that they were in 2 parts, like 2 halves, but that's okay. You go right there, right? And in real life, you can get rid of one of these washers and make this, or yeah, get rid of one of them. Keep the other one there because you're going to need it, but you can get rid of one of them and then you'll get a lot more space here. In real life, you'll probably also be able to fiddle with all of the surface spacing that you get here, so that to make this actually clear. And like, it won't be as tight as it is right now in real life, because right now it's basically touching. But if you saw in the last video, we replaced this screw, this nut, sorry, and just did one washer, and it fit a lot better. The reason we can't do that here is because when we do this sort of thing, when you squish it this way, and then you go to build the 4-bar assembly up here, it sort of breaks. So we can try doing it with just one Teflon washer, and it'll give you more space, right? But that means that this rear linkage is shifted in just a tiny bit compared to the one in front, so you technically would need this washer up here. And last time I tried it, it didn't work because of whatever way the spacing worked, and you also need a spacer. I didn't realize. I don't know how you're staying together, but okay, interesting. And then let's just try to constrain this together. Oh, people outside are moving and they've got a loud ass truck. Okay, that's sort of annoying. So then you constrain these two together, and supposedly this intersects, but sometimes when you try to do it not perfectly with like inconsistent spacing, it breaks. But right now, today, it seems to have worked, and then you see you've got a nice amount of space for your wheel to clear, and you can get even less if you just use a thinner washer, or a thinner nut, sort of. Let me close my window. A thinner nut, and then you'll get even more space, and the amount that it's marginally shifted here for the gears really will not matter. We use 2 Teflon washers because Teflon is the least friction that you can possibly get, but you can get a lot less. These screws are sticking out. We're just going to bring in, for the sake of completion, we're going to bring in some thin nylocks. And thin nylocks work just as well as regular nylocks. They're just lighter when you go to build, which is something that you're always going to, like, yes, getting a heavier robot is going to be better sometimes, but if you build the entire robot lighter first, then you can decide where you want to put the weight later, so it can actually help you with your weight distribution. If you just build the robot with heavy parts, and it is heavy, cool, it's heavy, but now it's heavy, and what are you going to do about it? Because then you have to go through and clean everything up again, and that's honestly not the most fun and exciting thing to do with your time. So build lighter, and if you need more weight, then you can really low on the robot, like on the base or something, strap on steel, and then that'll be better for you and your robot. Okay, and then hopefully we can copy and paste this wheel assembly over again. Minus a washer. Yeah, minus a C-channel, minus a washer. Minus that, and this is going to stay the exact same. No, not you. Did I do it right? Did I do it right? I did it right. Look at me go. I'm so proud of myself. Also, yeah, my mic sounds terrible. It's because it just doesn't pick things up. So, we're going to have to boost the audio by like 500%, and then you just get all of the background noise and all of the, which is not fun at all. So now that this is done, you can see that it is indeed like completed. You know, we've got this thing in the back, you've got the other side. It's not completed as well as I would have preferred, because you're still going to be, oh frick, I have just realized something. This will not work in real life if you don't use a screwdriver. Okay, so this is when we have decided that, okay, look, this is going to work the way we intended it to, entirely. But we know that this assembly type thing fits, okay? So we're going to copy this, not the screw, but the bearing. I'm going to put this down, and the reason this won't fit is because there's not enough space here for for a shaft to go through, and I want to use 4-inch wheels just because that way we can keep 200 RPM. If you wanted to make this slightly easier, just do 3.25-inch wheels and everything would be so much easier. But unfortunately for all of you guys, I want to keep 200 RPM on 4-inch wheels because that's what I feel like doing. So we're going to delete these, and then we're going to constrain in the nut assembly that we had. So this thing here, we're going to constrain that in. Again, we're going to put the nut against the metal because you want the rotating thing to go against the nut. I think that's in line. It is in line. Well done. And then this is actually going to have to get pushed out a little bit more. Oh, no. To meet the Teflon, but that's okay. Because what we have planned next is quite interesting. So the goal here is to get this screw, or whatever, to get this gear to be able to spin freely, right? And you'll notice on these other 2 big gears, you've got, I'm really bad at talking while I'm doing something, sorry. You notice on the other 2 gears that we've got the screw going through the aluminum, and then on the other side you've got the nut, so holding it down. The same principle can be applied here, except we won't have space on the other side for a nut. So what I'm thinking is, if you take a screw, we're going to go conservative and go for a 7.75-inch screw. We're going to try to do this. That will clear if we know what we're doing. Again, shave it off here a bit. You don't even need to run an insert on this side. You can shave that insert down a little bit, save some space there. It will clear in real life if you make it work. Now and that is way too short. Also know that, why is it not deleting itself? Hello? Okay. Also know that you can build this entire assembly using thin gears, low strength gears, and it will also work just fine. I'm using high strength gears here just because I do enjoy using high strength gears, because you know, you can put a lot more power through them, torque through them, and have them be okay. But let's say you wanted this to be even more conservative. You really didn't want this to touch. I'll let you in on a secret. The low strength gears and the high strength gears are actually the same width across. The power where they connect to the shaft is going to be the same width across. It's just that high strength gears they don't have teeth the entire full width, it's only a little bit. So then if you put this down, you'll notice how this is exactly the same width. I can constrain this onto there, and it should in theory constrain perfectly if I pick the right circle. The CAD software is saying it doesn't. In real life, it will be so close you cannot tell, and then bada bing, bada boom, you've got this much more space to work with. Yes, this gear is going to be that little bit weaker, but you've got now this extra clearance, this extra space to work with, and that's pretty cool if you ask me. Do note you will have to drill these gears out because they only come with the square shaft sort of inserts, but let's say for this gear we wanted that extra little bit of space for that peace of mind, we can do the exact same thing. On this side, again, you can use a high strength gear with a screw going through there, that will work too. Or you could take a 60-tooth gear, if I can drag it in without fail. We're actually going to, because this is an idler gear, we can do something a little bit more fun with it. So I'm going to delete this component. I'm going to make a copy of the component, and then I'm going to rename it to something different so that Inventor doesn't get confused. We're going to open it up again by double clicking, and then what Inventor will do, it'll open the part up, right? So just what I want to check is, let's check the distance between these two. So there's 0.063 inches of distance between these two. So for the memes, and just as a demonstration, we're going to extrude, create a 2D sketch on this face. We're going to create a rectangle just around this area, right? And then we're going to extrude this. We're going to go 0.063 the other direction, and then you'll see that it basically deletes the part, which is pretty cool. You could go a little bit more if you want. You could probably go measure from here to there, which is 0.148 inches, and it would delete all the way down so that there's nothing there. But then you've got like this weird square thing, and getting a screw into there is kind of difficult. So I'm going to, for today, just go 0.140, and that leaves us with just a little bit here. When you actually do this in real life, you'll probably want to leave a little bit more, so 0.1, because that way there's still something for the screw to sort of sit against, even though you're cutting a lot of weight. And when we're done, we hit OK. Why did you fail? No, I don't enjoy it. We're going to try this again. Okay. Okay, we're going to close the part. No. Open it again. Start 2D sketch on this face. We're going to build a giant rectangle. Finish sketch. I'm going to extrude this way by that much. I don't know why you're failing. And that annoys me a lot. Okay. Why will you not work? Extrude feature failed. Errors occurred during update. That's actually cancer. Okay. You know what? I'm going to extrude on the other side. No. Cancel. Start 2D sketch. Circle. I'm going to extrude. Back down. Profile. This one. Annoying. Okay, you know what? I'll figure that out later. And I'm going to just drag the 62th gear in. I'm going to constrain it onto the Teflon. And now you've got that little bit more space to work. It's still the same width as a regular 62th gear, but it's just a little bit nicer. So in real life, you would cut that down by however much, and you would put in your Teflon washer, right? So it would be your Teflon washer, which is where washer spacers. Teflon washer. I would do 2 again, because that seems like a good number. But for now, we're going to do 1, and hopefully your listing intent will be enough to know that I'm not actually stupid. We're going to use a long screw, and I'm just going to be putting full extra on this one. And then you're going to put that onto there. No, wrong way. Okay, so this clears nicely, and then the screw is too long. Darn it, cleared myself. Okay, I'm going to try again. So the screw's going to go through. In real life, you're probably going to play with the screw. Now, This looks like it won't work because you'll just bind down on this nut and then it'll just bind down on the screw, right? But what we're actually going to do is we're going to take another nylock, put it on the other side, in real life it will clear because you will have done the shavy thing. Okay, cool. Now what you can do here is instead of having this nut screw down towards the screw head, if you screw it down just enough so that the gear can rotate freely, and then you tighten down that other nylock, then tighten the nut against the nylock, you can bind it against the metal and it won't come loose. And if you're really scared about coming loose, replace this one with a nylock, and you'll be fine. Or double nut it, doesn't matter. But basically they'll bind against each other, and then that's going to be what they're holding against. It's like you have a virtual screw head, and then you have the virtual nut. And then you have the actual nut, right? Because this on whatever end this is on would mimic a screw head, or this end would mimic a screw head if you could get it to a certain point of tightness. And then this gear is able to respin very nicely, and then you don't have a collision with the wheel. Does that make sense? Cool. So now that the drive is built, I'm pretty sure everybody knows how to put in bearings, right? So we're going to just skip that past that part. I can put that in later in my own free time. It doesn't really matter. Next thing that we're going to work on is we're going to try to create the frame for all of the rails to sit on. This thing has got to go because it's really in the middle of all the gears, right? I'm thinking if we put one in the middle between these two gears, that would fit nicely. You might be able to get one in between these two gears, and I really want a half, just like a half seat going across the back here, so that when we're backing up, we don't, get trampled over by like cubes or something. It'll just give us something so we could build off of, like put a few panels or something onto, so you don't like get stuck on something, So we're going to copy paste this 2 times. Now we've got 2 of these C channels. We're going to get our wonderful thing. It's called spacers. You want to use nylon when you're building these. It's going to make, like, bearings are great and all because they squish, so you can get really strong connections. But when you're building, where are my washers? Okay. When you're building it onto the frame, you want them to not squish, because if they squish, then your frame is going to start warping in weird, wacky ways. So we know it's going to be more than half an inch to get this to stay. What we don't know is if it's going to be much more than that. So half an inch, and then we're going to place half an inch on the other side. It looks like that's not going to clear super great. We're going to need just a little bit more spacing. Oh, come on, don't give up on me now, computer. Oh, gross. Oh, and now you drag them in. Thanks. That should give us enough clearance where we're able to take the C channel. It should. Might not. And let's see if it does. Yeah, it does. Where we're able to take the C channel and put it across. Okay, and then we're going to do, I think it's the same because you're limited by this. So we're going to need 1, 2, 3, 4, 5, 6 of these. And we're just going to go ahead and constrain all of them to the bottoms and tops of this chassis. And we're going to slowly go through all of these. They look like they're really close together here. They will fit in real life just fine. Do not worry. They will fit fine in real life. And then the other one is here. On the other side, it would have been where? Here. And then we take the C channel and constrain everything up here. And you'll notice that when we build parts, we don't actually need to rotate the C channels. We just sort of constrain them in, and then they'll rotate to fit sort of the direction that they need to be in. And you're not constraining because of what? There you go. So now you've got these 2 channels going across the bottom. They both, I think, clear the gears. Okay, this one really doesn't. So it looks like they'll both need like maybe a washer extra. No, you're fine. They'll be fine. Now, this is something that, now we can get rid of this one! Oh, that's so fun. And we're going to ground these two so that doesn't move around. Grounded just means that it doesn't move. Now, we can't drag this around. This moves. I forgot that I unconstrained it. And we're going to actually pretend this Teflon doesn't. No. We'll just constrain it using the second Teflon. Yeah. Like, in CAD you can hack it this way. And there's going to be a difference in the two sort of like depths because they're not in the same plane. But we're gonna set that as a distance. No. Okay, now that's grounded, we can constrain. Oh, I hate this. I'm gonna constrain that part to that with an offset of that plane to, no, with an offset between you and, oh my god, this is so difficult. And, no, I need, okay, we're gonna delete the Teflon and put it back later. No, wrong one, kill me. Okay, we're gonna go from here to here with an offset of here to there. Why are you not working? Or we just do a megaplog thing and we delete this entire friggin' gear and go back to what we had before so it was working. So in real life, yes, it's possible you'll get a little bit of weird spacing issues. I'm not in the mood to deal with them right now. Sorry. Where did Teflon go? I'm so confused. And the beast that I have not built yet has already eaten a washer. Wow, look at that. Okay, now this should stay if I move it. Ah, yes, exciting. Okay, the reason we wanted to put these again on the bottom is so that when you slide the cubes in over top, there's nothing interfering with the cubes themselves. Make sense? Hopefully makes sense. And then last thing I said is I wanted a little brace on the side here. It looks like this is the most you can get. Oh, before I do that, we're going to show you something called box bolting. I'm only going to do it on one side before I just go ahead and do it on my own. Or before you guys can go ahead and do it on your own. I'm not going to... When I first started this, I was like, yeah, I should make it really instructive because I can't talk, right? So I should like CAD in everything. But now that I can talk, I'm just like, yeah, I can do it once, and I can tell them to like just repeat it, right? So hopefully you guys can do that. And when you build one of these C channels, you're gonna have to pick one to be the C channel that you sort of start the build off with. I would pick this one because it's closer to the middle. And when you build this one, you're going to need to consider a few things. I'm going to use regular hex nuts and thin nylocks. You can use thin hex nuts and thin nylocks and all the fancy things if you wanted to, but right now I'm kind of just being lazy. Okay, we're also going to need some bearings, and this is something that people have very, very, very mixed feelings about. And it's something that I do only on the first C channel that I actually like put in, and I do it on both sides. So what you do is you put the bearings in however you want, okay? Because the bearings have got 3 holes, you only need to use 2. Now that those are put in, what we're going to do is we're going to box bolt. Box bolting is basically the bolt goes in from one side, it comes out all the way on the other side, like this. Pretty cool, huh? You don't need this to be a full 2 inches, you can cut that off later if you really wanted to. But for the sake of today, I'm going to ignore that. Now, if you just tighten this straight down like this, it would not be fun. You would bend the C channel, okay? What you can do is you can take, I believe that would be 1/2 inch. You can take a spacer like this and put it in. Oh, sorry, my bad. 0.375 minus 0. Yeah, you need 0.375 spacer, sorry. Add a little bit, and then that will fill nicely, and that's one way to do it. The way that I prefer, at least when you're starting off the build, is to do this. This does mean that you got, like, it would not be a bad idea to put one of these on the side, because this would give you sort of the proper distance that you need to get between your bearing and your C-channel. And bearings squish a bit, so even if this Teflon here is sort of intersecting with the bearing, you'll squish right through it. If you then take a screw and then screw through that, let's just grab a screw and a nut. What you can do is you can screw through on the side before you actually go to build on the C-channel. Just like that, tighten it down, and then that'll give you a good reference as to how tight these nuts should be and how tight, where did that nut go? What? This should be. Okay, because you shouldn't be deforming the C-channel. These two nuts should be pushing outwards with the same force that these two are pulling inwards, so that the C-channel stays parallel. You just get a lot of bracing. So you do this type of screw on and bearing system on these two and on those two and on the other side again, right? Because what this allows is it allows these channels to help become, like, they become basically incredibly parallel. Then when you actually go to build the rest of the robot, I would do box bolts on the drive, and on the outside it's kind of ugly to have like bolts going through up top, isn't it? Especially the nuts, but it's a lot easier to access. So it's entirely up to you which way you prefer to put them. For me, I prefer to put the screw heads on the top and then like bolt through this way, just because yes, the nut is harder to get to, but it looks cleaner, and then if I ever need to put like something on top, it'll work out anyways, right? Because I won't have to deal with the nut interference. And obviously switching it isn't hard at all. One other thing to consider is if you do it from top to bottom, if you want to bolt something onto this top rail, you're going to have to undo the entire screw. If you're doing it from bottom to top, the nut is easier to take off on the top, so if you're bolting anything else on top of it, it'll be easier to do. So you're going to do this, because I told you so, because it's a superior method. You're going to put this up top, and then you're going to take your two caps nuts. Caps, not regular hex, they will work the exact same. Caps will offer you a tiny bit more peace of mind. Do not use nanox, you will want to kill yourself. These two go up onto here, and then ta-da! Box bolt. On the inside, it's very different. On the inside, what you're going to need is you're going to need a 1/2 inch spacer and a 0.375 spacer. And instead of using two cap nuts on the middle, you can if you want. Okay, I'm not stopping you. I'm just saying if something goes wrong on the inside and you need to repair it, it's going to be hecka difficult. And then you're going to put this screw head down because you might need to get to it later. And then you're going to put a nylock on the bottom. And because you're not screwing anything in the middle, you can rotate the screw head to tighten the nut on the bottom, so you don't need to worry about that either. And then that way, if you ever need to put like a rail on top here, or slide something across, let's say like, I don't know, a cube, it's not going to be super bad, and it's going to be a little bit better. This is also going to be a little bit lower maintenance. It's not going to be as like sturdy per se, because you won't have it biting against both sides of the C-channel, but on your interior C-channel, because you've already got this brace and that brace, I think that's more than plenty, especially if they are both technically box braced, you're not going to get a lot of flex. On the back, I want to do something below, and it looks like the most you can get is just two. 1/2 inch and an 0.125 before you scrape the ground. So we're going to see how well that goes. We're going to go 1, 2, and we're going to get a half cut, because that's fancy. Half 1 by 1 by, do I have one that's even long enough? Oh my gosh. structure. C channels, 1 by 1 by 1. We're gonna go 1, 1, 1, 30, and I'm gonna pray that yes, it works. Okay, half cuts are weird in the sense that you'll get more strength on the direction with more material. That's not weird. It's just that you have to consider that, and it's an effort. Yote and yote. Well, that looks like it clears with ease. Okay, so what we're going to do instead is we're going to undo that. And we're going to constrain it so it's a little bit cooler looking. And now the wheel will clear, and now if we're backing up into something, we've got something like a bumper to prevent us from like riding up over it. And then high centering. Which, you know, is always nice. Also, if you want to push something, you could probably turn that into like... Oh boy, let's see if this is going to work. Okay, C channel 1 by 2 by 1. We're going to grab a 1 by 2 by 1 by 30. Copy. Paste. Rename. Oh, I hit the wrong button. Rename 1 by 2 by 1, 1 by 2 by 30. Okay. We're going to open this up and let's see if we can get an extrusion to work this time. I'm praying. Create 2D sketch. Yes, I said yes a while ago. Computer, why are you so slow? Rectangle. Big. Extrude. Aluminum is 0.064 inches. And that way, and then you'll see that we've essentially deleted the side. I'm going to go more than that. 0.065? 0.07. Measure! Let's say from that line to no. That's a little bit extra, isn't it? Yeah, that's a lot of material. What happened? No. We want to go from... How do I select this face? I'm so confused. Okay. This is 0.064. Yes. 0.064. 0.084? Ah, close enough. Yeah, that looks good enough. Cool. We're going to delete this one. And then it should get rid of that row because that's all just a rectangular pattern. Should. Whatever. Delete. Okay. Save. Come on. Ignore this one. Delete this. And now use our wonderful new 1 by 2 by 1 by 30 that we just made. And then we can constrain it this way. I think this has to go into here. And this has to go into here. And that's going to get you a little bit more strength than that 1 by would. And it's also a lot more weight. And not entirely necessary, but that's all for today because my throat is dying and I want water. Cool. Bye-bye.